This is the integration packet number 2. It's problem number 1, and we're asked to find the region R that lies below the curve y equals root x and above the x-axis between 1 and 9. I have taken a moment to include just writing down how many rectangles we have. It shows that we have 10 rectangles given. And if we have 10 rectangles given, then to find our delta x, we have to take our boundaries, 9 minus 1 divided by the number of rectangles, which is 10. So our delta x is 0.8, which I have shown 0.8 in here. Okay, it's that x width between the between each, it's the base of each rectangle. So I have also taken and calculated what our x values would be on each of the rectangles that we're going to use to calculate to estimate the regions, the area of the region. Okay, so I have completed the first question, part A. We are trying to calculate the area under the curve of the rectangles, given that we figured out what the x coordinates are, and I've done a little sketch right here just showing a little bit of what I talked about already. So since we're trying to add up a bunch of rectangles under these curves, in order to find the area of one rectangle, well, I'm just going to take the base, okay, which we found out our base is, on all of them, is delta x, which is 0.8. And then I have to find my y value of the right hand side of the rectangle. The left hand side of the rectangle does not intersect with the curve that we're talking about. So its value we cannot calculate, although we know it's the same value as the right hand side. We can, because we know what the function is, being the square root of x, we can find out what the height of the right hand side is. So since I'm just doing the area of a rectangle, it's base times height. So in the first rectangle, my area would be 0.8 times whatever my function value is at 1.8. The second rectangle would be my base, 0.8, times my function value at 2.6, plus 0.8 times my function value at 3.4, plus 0.8, my function value at 4.2. And I'll just keep going here. And my last term is going to be my base, 0.8, times my function value at 9. Now notice we're using what are called right-hand rectangles. And so we're using the right-hand side of each of the rectangles to calculate our heights. Now, the other thing to notice on right-hand rectangles, we never use the left term of the values between, like we were going between 1 and 9 in this case. We won't use the value at 1, but we will use the value at 9. So if you take and use your sum and sequence information, we have our sum. We need to multiply that, each of the terms, by delta x, so 0.8. And then we need to have our sequence. and our sequence is of the function root x. Go through the values of x. We're going to start, our first value that we're going to start at, again, is the 1.8. We're going to go all the way up to 9, and we're going to have our steps by 0.8. And if you do that calculation, I believe it comes out to 18.116. So the area that we're going to have, a sentence we can write about our area is, our area is an overestimation of the actual area. Again, using our calculator to approximate the area of R using 100 rectangles, well, that just means that our delta x is going to be our endpoints subtracted from one another divided by the number of rectangles. So instead of having 8/10, I'm going to have 8/100. And you can do the same thing, sum times our delta x, our sequence, our function. Now we're going to start at 1.08. We're still going to go up to 9, and we're going to go by increments of 0.8. And I think you get 17.413 on that one. Now the rectangle below here, notice how on this rectangle we are using left-hand rectangles. Because the left side of the rectangle is intersecting the function, so I can find its value. Now, notice how at 9, it's not actually intersecting the function value. So we're not going to use 9 as one of our values in our sequence, but we are going to use the value 1. So on a left-hand rectangle, we use the beginning value, but not the end value. On right-hand rectangles, it's just the opposite. So if we're going to use 10 rectangles, then we're at the 8/10. So we're going to have the sum 0.8, the sequence of root x, x, starting at 1. Now we're only going to go up to 8.2, will be the last term there. Going to go by 0.8. Now look at the 5 values that you had. You had the value of 18.116, you had the value of 17.413, and now we have the value of 16.52. Take a guess. What do you think the actual value would be underneath this curve? On this particular problem, we have an underestimation. So that left-hand rectangle on an increasing curve, it gave us an underestimation.